Hi everyone and welcome back to our channel. Today I want to show you simple alarm based on Blynk and ESP. First of all, I will show you what Blynk itself is capable of, then I will tell you about hardware, and after that about the code. Alarm system is currently disabled, as you can see. It's a simple label value, widget lab, widget button, widget RTC, mail, push notifications and Twitter. And here are some random numbers just to show you that everything automatically updated, everything is connected. It was actually added more for debugging than for any actual purposes in used Sketch. Anyway, you can display temperature here or anything else. So right after I push this button, I switch it into protection mode. Widget color changes. I receive push notification with time when it happened. Same notification is sent to Twitter and to email. Protection from 50-second delay is not yet realized, which means if you send messages more often than 50 seconds, they will just not be received. And it may probably cause disconnection, but I'm not sure. Okay, I suppose 50 seconds already passed. Let's go here for motion sensor to detect us. So now I was on the other side. Buzzer responds immediately, intruder was detected. I receive push notification, email, and the same in Twitter. Everything is very convenient. Okay, let it buzz a little bit. Our buzzer LED on ESP started to light, signalizing the alarm sounded. Okay, enough buzzing. Let's turn it off. It's been enough for 50 seconds, so every message should be already sent. Wait a bit. Alarm is off. Intruder was spotted. Alarm was disabled after intruder was spotted. Date, time. Everything is shown in push notification. Same to Twitter and email. So as you can see, the text is displayed on label value, easily as some temperature detector. Easy way to send ourselves current state of the system. It's very convenient. Now let's go and check out Twitter and email. Check out messages, time delays, and how it receives messages. Here is my mail, let's see what we have. Okay, alarm is disabled at 18 hours, 11 minutes, 46 seconds. Alarm activated at 18 hours, 90 minutes, 22 seconds. Intruder was spotted, it was me at 18:20, and alarm was disabled after intruder was spotted at 18:20:43. So we received all messages in time here. Now let's check Twitter, refresh the page. Alarm disabled, okay. Intruder was spotted, alarm activated, alarm disabled. All messages here received as well. I consider it as a success. And now let's find out about the code. A bit about hardware. I suppose everyone knows ESP, this shield board from previous video. I highly recommend it to you. It's easy to make prototypes using it and no need for drive board because it has everything needed. Another thing is motion sensor. The important thing is it must be connected to plus output of ESP board. To port in, it has 5 volt from USB. Not output, input. Anyway, it has 5 volt from USB as well. Same voltage. In other way, it doesn't work because on output it would have 2 and 6 volt and not 3 and 3. But if power is 5 volt, output will be 3 and 3 volt, and you don't need no additional stuff to mess with. This is a passive buzzer, I will tell you more about it later. Using it, I would like to play Star Wars theme and Super Mario. It just reminds me of Dandy, Atari times. Also, we can add relay here, as it's said in the code. Okay, all links to hardware will be in the description. Notice that button is pushed, but there is no connection. Device is disconnected. Let's get power to it. Turn it on. It buzzed 3 times. 2 times, which means disconnection established. Here we already have data that it is in protection mode. Everything works perfectly. All information was sent. Let's see about the alarm. Push notification was sent, which means all other messages were sent as well. Alarm went off, signalizing that intruder was spotted. And... no, it's fine, relay is working. Relay is working. Everything works fine, guys. Now there will be a plenty of boring explanation about the code, but I suppose it's worth it for people who want to repeat after me. First thing you need to do is to click File, Properties, and check options Show Number of Lines and Enable Folding. Will help you greatly while creating any sketches. So here I left my personal links about the sketch, links to modules, same you can find in video's description. What's the point of the sketch? I marked widgets, about RTC. By the way, check it out. Real-time clock, push notifications, mail, Twitter. You can disable any of it. I will show you where. I mean, you can use only those which are required. Of course, I will show you where to disable, but it might be not enough. In case of some issue, bugs, fix it by yourself or ask me your questions. Okay, right here disable uncomment Blynk debug and Blynk print serial. If you uncomment it, performance will fall by 10 times. But during code debugging, it is very useful to have these lines uncommented. By default, message is 120 symbols, and if you type in Unicode, I mean in Russian, it's necessary to increase this amount twice. For ESP, it's 1200 maximum, I set at 600. Here are libraries of ESP and Blynk, libraries on ESP firmware, libraries on real-time clock. Here set inputs and outputs. Remember I said about GPIO, you can type D1 here for example, and only with pins D. Works only with D pins type. So, on GPIO 5 goes per sensor, LED goes on D4. Notice that it's inverted. If you set it here, then keep that in mind. On D8 there is a relay. I didn't connect it, by the way. Doesn't matter. On D7 we have a buzzer. Here are colors. Here are some personal data, authorization key, login, password, email, name of the message sent to email, what there will be in the message you will receive. You can change it here, type in Russian or left it in English. Widget RTC, initialize real-time clock timer. Initialize Blynk timer. Here we create ID for speaker ID and for per sensor. The point of creating those is that we can turn timers off and activate only when they are required. First of all, it saves RAM space, and secondary, it's easier to manage. Which means timer will not trigger per sensor function until I activate it. I will show you further in the code. Initialize widget LED. By the way, this widget is absolutely useless, because I change colors of my widgets and its notifications by myself. But let it be. Variable for the storage of the state was connection set for the first time. Initialize variable for the storage, and so on. Everything here is written in detail. I guess it's time to go to the code itself. If connection was set for the first time, Blynk connect, then synchronize all widgets. So if there was no connection yet, and you push the button to activate your alarm system, then when ESP will set connection for the first time, for example, if power on your perimeter was lost and later was restored, it synchronizes with you and launch turn the whole perimeter to be guarded again. So if the power was lost, it will resume protection when power is restored. Email. I personally don't send to email. There is a standard form of message, and here is my own form, and you can add your own. It's needed when you turn on the device. Read per sensor. It's important to have here static. Look through this info. The whole code I wrote such way that nothing will happen until we turn on the alarm. So until the alarm flag protection is low, until it is low. Per sensor status is not needed for us. We won't even request for motion sensor. Blynk write. As you can see when I fold it, it's much easier to read. Blynk write reads the status of widget button. And therefore, it's very interesting. If flag protection is true, the flag is up. Then we turn on the timer. Remember I told you about timer initialization. We turn it on. Otherwise, it will be turned off. But I notice a bug there. If it can trigger in time, per state will stay in the same condition. Per state will stay in the same condition, so you need to trigger it once with a timeout of 50 milliseconds. It's necessary to activate the function, and it will work just fine. Send in messages. Look at this. Send in messages, settings, and send setting. Settings to be sent. These are for widgets. These messages for Twitter, email, and push notifications. And here are settings for widgets themselves. Security state is responsible for all these functions. It will be interesting for you to see in detail. In message, when we trigger it, we do it 3 times. We trigger it 3 times because here are push notifications, email, and Twitter. If any of it is not required, just uncomment it and delete widget from the project. Then nothing will lag. Let it be uncommented. The point is, when we request for the code for the first time, it runs to this point, because here 1 is equal to 1. It runs further to this point and send to it. Add here to I plus 1. Next time it will send this line, then next time this line. What is it for? If we write this line one after another, then your device will not connect and email and tweet probably will not be received. So you need to set delays. At security state I set this delay. I will show you how it's done. I suppose it's better to show you right now. Here is security state. For example, the first state when alarm went off. We request for message function 3 times with interval of 1 second. So at 1 second interval, We send message to Twitter first, then to email, and then push notification. Otherwise, it won't be sent and it will freeze. Setting is the void function that has input variables, string color and string text. From where they will come from you will see later, but here is the same principle as it was in message. First we send text message about the current state of the alarm, then change color again, and then change LED color. So this function must be sent 4 times, but you can send right to this function because it has input data and syntax doesn't allow to send such functions. In order to send it, you must do it in security state. Let me show you again. This is security state. Here is send setting. Request for send setting function 4 times at the interval of 200 milliseconds. Request for it 4 times. Send setting includes switch operator, that is from security state, tells which case do we have, case 1, 2, 3 or 4. And so we choose type into string notative text. You can change text here for every case, and color, blink red, blink green, blink blue twice, because upper one in a case of intruder and lower one in a case of no intruder. And what happens here? We apply to variable notative and color required message. Then at the end we request for setting function color notative. Request this function. And in this function we go to this point, type needed text. Second time go here and type color. For the third time again, type color. And for the fourth time, color as well. So it works kinda like that. If you just do it otherwise, then your device will disconnect and something won't be received. I just tried different ways and this one is the best. Okay, void security. Okay, so when function if and also else if are piled up, it becomes much easier to read. State 1, state 2, state 3 and state 4. This state, entering in this state, happens only once. In order for that, we have security state here not equal to 1, which is state 1. When we open it, for example, in case when detector triggered. In order to enter this state, there are some terms of what must be done. If protection mode is on, detector triggered, and not in state 1, we execute this code. We go here. Security state 1, we set number 1 of alarm state. It is used as well in message and in send setting. Intruder state equal high, alarm triggered, timer, set timer. We send message, activate relay, request for send setting function by 4 times at the interval of 200 milliseconds. We send settings to our widgets and enable timer for speak buzzer, which means we activate function speak. We turn on timer that triggers speak function. And now let's fold it and look at the function itself. We have void speak function for buzzer. Everything is primitive here. Just set frequency and duration of buzzer. Do not increase duration. Otherwise, it may cause freezing and disconnect from Blynk because this duration is basically a delay. And about buzzer, we set it up previously. Right here is send data option 1. By the way, I'm going to make another video about sending data. And what's the point of it? It's important to set only push in widget. In reading rate, I'm going to show you where it is. Let me just turn it on. It's very important. It's very important. Okay, right here is reading rate push, which means it's not widget who requests for its current state from hardware, but hardware itself send data to widget, and so it will be updated by hardware and not depending on how we set up our widget. As you see, it's a big difference. Here we have a description about what's happening. It actually doesn't play any role in the sketch, except the fact that it greatly helped me during debugging, because I could immediately see if there are data update on temperature field. If there was an update, that means connection is not lost and timer does not freeze, and hold device as well. Reconnect Blynk function. If currently we are not connected, then we make connection, display in log that we are reconnected. If not, display that we are not reconnected. Simple function, we will trigger it once in every 30 seconds. Void setup. Launch serial connection with port monitor. Set inputs and outputs. Notice that LED is high, on physical board it's inverted. Because if it was not inverted, if real portable LED would be connected there, then you must change the code in places with variable LED. In order to do it easier, just select variable LED, press Ctrl F on your keyboard, and find every place with this function, every place where variable LED is activated. And then invert it. It's not very difficult to change it. After that we set a delay of 1 second and 3 times trigger our buzzer. Because of that, I know that my device successfully passed initial configuration. Everything was loaded and nothing bad happened. Next step, we connect to Blynk. I already told you about it in time input widget. Then set timers. Let's have a look. A default line timer set interval, but if before it you write equal and time per sensor, and also ID for easier navigation, then we will find out a number of timer. This one's number is 0, this one's number is 1, and then disable them because they will activate in other place of the code, and they shouldn't be activated here. Because there was a case when buzzer had time to trigger several times. It had time to buzz several times until security stayed activated. Why I set at 3 seconds? Basically you can set at 5 seconds. Doesn't matter. Because if motion sensor will trigger, this state will not be changed until we reset the alarm. And that's why in any case, will it be 3 seconds, 10 or even a minute after, when we check security state and if sensor triggered. This variable will not be changed even if intruder will leave the area guarded by the sensor. And if sensor will stop showing number 1, even in this case, it will stay in mode intruder was spotted. Something like that. Set interval for reconnect for sensor once in every 2 seconds. I don't advise to update data in Blynk very often, because it also may cause disconnections. Launch real-time clock widget. Don't forget this line, otherwise widget will not work. On email you will receive messages dated like 1970s. I couldn't understand why that happens for a long time and reminded that I forgot to launch it. Here we set widgets, turn LED on, because if it will be off and we won't turn it on somewhere else, then no matter how many times I will try to change my LED color, there will be no difference because it's off. As well, you can write LED 1 off and turn it off this way. Blynk has such simple syntax. Change widget's name to V10. It understands not only English but Russian as well. Defense status. It didn't understand at first, but I tried it only once. I guess it was a bug. Second time it was perfectly. Here are settings for Aduino OTA, for wireless firmware. You can left it as it is, but I have uncommented password line here. Password 4 zeros. What's next? If connection is set, it will buzz 2 times. If it's not connected to Blynk, it will buzz 10 times. Easy way to notice that something is not working. And right here, OTA is always ready for wireless firmware. If it's connected to Blynk, then we launch Blynk and timer run, launch run. And that's all about the code. Subscribe to the channel, like this video, ask your questions, tell what you want to see in next videos or something to describe you in detail. Goodbye and good luck!